Welcome to the session 6. So in this session we are going to discuss on these three topics. Hence, so far if I look at what we all discussed with respect to Java, it's about the introduction or a brief history, the Java's magic, the JVM, the JDK what we use, and the buzzwords of the Java and Java as object-oriented programming, and the properties what Java is going to hold whenever we think about it as a programming language, and the very first simple Java program, how the class should be used, how the main function should be defined inside the class, and what are different types of commands available in Java. And so now in this session we are going to extend our discussion with respect to the data types in Java, the Java variables, and the typecasting which happens in Java programming. Fine. Hence, if I talk about data types in Java, so usually this data types in Java is going to depend upon two main options, or we can say the two main properties of data type. The first property what the Java is going to mainly depend upon is every variable as a type. So it is as usual in every C programming, every expression has also a type. Every type is strictly defined. So this is the keyword which you should look out for, because in Java every data type or every type what is involved in an expression or a variable, it is strictly defined. I will tell you what exactly this is going to mean when we put the word strictly. And the second property is all assignments, whether it's going to be explicitly mentioning in any arithmetic form or passing it as a parameter for any functions or inbuilt function or any API. So Java is going to check for type compatibility. That is what it's strictly defined, and for this reason every type what you use will go under the scrutiny of its compatibility. Hence, now when I say data type, it is not going to be as casual as in C and C++, though all these data types are similar to C and C++, but there is some enhancement or improvement what it has been made. Hence, for this reason, so no automatic conversion of conflicting type is going to happen in Java. Even this is the same with all other C program, but it is strictly maintained in Java program. And so now it is going to check all expression parameter to ensure the type compatibility. So what the second property I have just told. And so now if I just look at the primitive types, and if I just look at the data type and primitive type, so whenever I say going to say primitive type, it's the basic data type, and we have came across a number of primitive types until now, and the famous one so frequently the primitive types what we use or is going to be integer, character, float, double. So the frequent one which we are going to use, and there are many more available in even C and C++ program, and few more available in Java program. Hence, so right now we are going to say there are 8 primitive types of data. And when I say a primitive type, now this is going to be the 8 primitive type. That is, we are going to have byte, we are going to have short, and int, long, char, float, double, and boolean. Now these are the 8 primitive types. Out of these 8 primitive types, few you are already familiar with using with C and C++ program. So few types is going to be the new one to you. Hence we will see what exactly this are going to be and how it is going to contribute to our Java program. And now when I say 8 primitives of data, and if I just look at fine, if I just look at these 8 types, and I'm just going to give what are the basis of this data type. That is, when I say a primitive type, the primitive type is going to depend upon basis for all the other types of data we create. That is, the primitive types what we say, this is the basic types, or even we can call this as simple types. And this simple types is going to form a basis to create any other data type. For example, if I want to create a pointer type, I need to use any one of this. If I want to use an array type, I want to use any one of this. If I want to create a class as a new data type or an object, I need to use any one of those as its members. Hence, for this reason, we usually say the primitive types or the simple types is going to act as a basis for any type of data what we are going to create. And all these 8 primitive types or the primitive types is going to represent only single value. When I create or declare a variable for byte, it can hold only one value. If I say integer, it can hold only one value or a single value. Hence, that is what the primitive type is going to be. Whereas if I talk about non-primitive types, something like array is going to hold n number of value depending upon the size what you're going to define. And if you talk about a class, a non-primitive type, again the class can also hold number of values or multiple value depending upon number of data members what you have been defined. Hence, so with this we are going to say the primitive types is going to represent only single value whenever you're going to use it. So now Java is completely object oriented, we are aware, but still these primitive types are not objects. So they have left this primitive types to stay as basic primitive types only. They have never tried to convert this into a class or object. So primitive types into objects would have been degraded performance, and for this reason they never made this sort of primitive types to be converted to any class or an object type. All data types have strictly defined its range. This means, I will just take it as an example what this sentence is going to exactly mean. Now if I say an integer and if I ask you what is the size of integer, right? So somebody say it's 2 bytes, someone say it is 4 bytes, and even at some architecture it's going to be 8 bytes. So there is no any strict defined range for an integer or a defined size for an integer. It depends upon architecture, it depends upon the platform what you are going to use. But Java is not going to do that because it needs to cope up with the portability on whatever the system we are going to use, whatever the architecture is. So it has got enough portability to execute itself on any given system. And for this reason, Java will make sure integer is going to be always of a defined size in whatever the system you're going to create, and that is what the strictly word is going to stand out for Java. Fine. Hence with this, if I just going to look at the primitive types in Java, whatever I have been just discussed, the 8 primitive types has been divided into 4 categories. That is, I am going to have byte, short, int, long has been put under one category, and the float, double has been put under second category, char third category, and the boolean the fourth category. And this category has been based upon the types of values what is going to store. Now all these 4 types will store integer values, and this is under the integer category. And this 2 type is going to hold floating point numbers, and this is under the floating point number category, and this will hold a character under character, and this is going to hold a boolean value, hence we are going to boolean value. Fine. Hence now these are the categories what you're going to put. Now we'll just see one by one what integer does, what floating point number does, and what the character does, and what a boolean is going to do. Fine. So now if I talk about integer type in Java, so the data type what I discussed now, it is almost same what we have already learned or what we already know with respect to C and C++. It is 90% it is intact. Only the 10% has been modified, a slight modification in Java. And so just look at those modifications, because I will be not going in detail what exactly all these types are going to be, because you're already aware of all this. Hence, I will just give the abstract level of information what you need to understand with the data type with respect to Java program, saying you have enough knowledge about the data types with respect to C and C++. Fine. And so now just look at this. Fine. So now you're already aware of the int data type, and even at some extent you are aware of long data type. So now we'll just see how exactly this is going to behave. And so now when I say integers, so Java does not support unsigned qualifier. Remember this word. C and C++ will support unsigned qualifier. Java will never support unsigned qualifier. This means, for example, if I just say int a, if you remember, if I just say int a, this is going to hold negative value as well as positive value, right? Yes. But when I say unsigned int a in C and C++ program, so this means now a is able to only hold positive value. Negative value is not supposed to store in this variable. So fine. Hence, that is what we call this as an unsigned qualifier. Now there is no such qualifier in your Java program. You can just say int a. There is no keyword called as unsigned, hence there is no unsigned qualifier. And the reason why the unsigned was used or is used in other programming language like C and C++ is that so to just maintain the higher order bit, just for the purpose of higher order bit. Because when I say unsigned, the higher order bit will be made 0, or this 2 bits will be used, this 2 higher order bit, that is, if 0 is the lower order bit, 15 becomes the higher order bit. Whenever you're going to talk about 2 bytes, 2 bytes is 16 bits, and starting from 0 to 15 there are 16 bits, and we call the last bit as an higher bit. It's going to be the higher bit for B. And now depending upon this higher bit, we will say it is an positive number or a negative number. If I want to store 10, I will make this as 0, stating it is going to be a positive number. If it is minus 10, I am going to have the higher bit as 1, stating or significantly saying it as a negative number. And I'll be using the remaining 15 bits to store the information or to store the value. And when I say unsigned, this is removed. Higher order bit is removed. All the 16 bits are used to store the value. Because when I say unsigned, every value what I store is going to be an positive number. And so now I don't need any higher order bit to significantly say me whether it's a positive or negative number, because every time it's going to be an positive number. And this is what the higher order bit is going to be. The C and C program will manage the higher order bit either by making it 0 or 1 depending upon positive or negative value, and in case of unsigned, higher order bit is removed. And this is how it is mapped. But Java is going to manage the higher order bit differently, which we will discuss later, which is going to manage differently with respect to C and C++ program, because it doesn't use unsigned keyword. Hence, whatever the variable we are going to define, it is going to always store the negative as well as positive value. Fine. So now this Java program is going to make use of a special shift operator called as unsigned right shift operator. Fine. So this is how it's going to maintain or manages the higher order bit. So now when I say unsigned right shift, I am going to shift the number of bits by 1 or whatever the value you're going to give to make sure we use the entire values of bits in our program. That is, by default, as we know, we are going to reserve 1 bit for significance of the sign of a value, either positive or negative. Now by default the Java is going to preserve this. It's going to preserve or reserve these bits for signed or unsigned. But I can use this, or I can remove the higher order bit by using unsigned right shift operator. Fine. So in later classes we'll see how exactly this is done, but right now just understand how the Java is going to manage the higher order bit and what do you mean by higher order bit and how significant it is with respect to any variable what we are going to use. And so now I've just put all these types. So all these types are similar. The way we are going to store an integer, hence the only thing they're going to differ is the size. The size or number of values what is going to store the range. For example, if I want only less range of numbers from -128 to 127, I'm going to use the byte type, and the size is going to be 1 byte and width is going to be 8 bits. If I want to use short, I'm just going to make sure the size is going to be 2 and width is going to be 16. If I want to increase the range, just use integer. If I want to still increase the range, use the long, and this is the range what I have just put over here, and this is the only difference between this 4 types. Fine. So next, with this integer we'll just go to floating point type in Java. So now again the floating point type is similar to integer. The only difference is the decimal point what you're going to use, which is going to float of times. So nothing much to discuss with this. It is similar to a C and C++ program, but make sure you're going to focus on this range. Again, the range and the size is still same as in C and C++ program. And now with this, we'll just move on to character type in Java. So now, just remember, so there is some sort of modifications with respect to character in C and C++ and the character in Java. So now Java character is not same as character in C or C++. When they say it's not same, it is not totally a different term what you're going to use. You're going to use everything same, but it is not exactly same. Is it fine? Because C and C++, if you remember, it's going to use ASCII character coding. It's going to use ASCII coding. Fine. Every character is going to have an ASCII value. Java is not going to use ASCII value. It is going to use the ASCII values. Along with this, it's going to elaborate or extends the list of characters. It is going to include few more codes, few more characters from the Latin, from the Greek, or any other language universally which is used. It is going to make use of all those characters in your character set. Hence, now when I say Java, Java is not only about the alphabets or the characters what you are using until now as a ASCII character. It has ASCII character as well as other character sets also. Hence, for that reason, we call this as Unicode. Hence, Java uses Unicode to represent characters because the Java program is going to work on internet on any system. Hence, so the system which is going to use Java program, if the system wants to display the character in a different language, Java should be able to handle this. Hence, for this reason, so Java is going to use Unicode to represent a character. Fine, that is what we say. Unicode is unification of dozens of character set, and ASCII is one set out of it. And so Java character is 16-bit type. Remember this. C and C++ character is 8 bits or 1 byte. Java is 2 bytes because it needs to, along with those 256 characters of ASCII, it needs to include other set of character also. Hence, it needs to extend its range. Hence, if we talk about C and C++, the range is only between 0 to 255. But now if you just look at this, the range is increased with 1 byte or 8 bits. This is what you should know about the character in Java. And apart from those, all those things, so declaring a Java and initializing the character, using a character as a literal, everything will be intact as in C and C++ program. Okay, so now just look at this, the Boolean type in Java. I think Boolean is a new keyword. You might have not used this. If you want, you might have used in C++ program, but it is not so frequently used one. But in Java program, we are going to use the Boolean type frequently. Hence, we are just going to discuss what exactly the Boolean type in Java is going to be. So now this Java is going to be used to store logical values. When I say Boolean, it's only two values, 1 or 0. So instead of saying 1 or 0, if I say it as true or false, it is going to be an logical value now. It's going to be a logical value. Hence, we say the Boolean is going to hold only two values, either true or false. And this type is used whenever a relational operator is used. That is, whenever you're going to use the relational operator, greater than, lesser than, and so on. All those type of operator is going to always returns Boolean type of value. And so now I need a variable which can hold the Boolean type. All these days what I was doing, I was using an integer variable to hold the Boolean type of values returned by relational operator, or the Boolean type result what the conditional expression was returning. So that is, if I use if condition in either conditional statements in if condition or in for loop or in while loop, in any case I was using an integer variable to hold the Boolean type result. But in Java there is a dedicated data type for that. You can use it as Boolean. It's fine. And so now we'll just see with an example how exactly the Boolean type should be used. Just look at this example now. I'm going to have a class. So inside the class I'm going to have my main function, and I have discussed you should understand what is this public static void main is going to be and the parameter what it takes. Fine. So now I'm declaring a variable now as Boolean b, and I'm going to say b equals false, because now this Boolean can hold only two types of values, either true or it can hold false, only two values. Fine. Hence b equals false, and system.out.println, I'm printing now something on the screen, and in system.println if you see a plus mark which you might have not came across, even in C++ we use this plus mark whenever I want to concatenate. When I want to concatenate two strings, I am going to use plus. So you can remember what is string concatenation: combining two strings or joining two strings or stitching two strings as one string. Hence we are going to have first string is b is with the space, this is the first string, concatenate with the value of b. Now this b value will be converted to string, and the string, this two string will be concatenated or combined. It's fine. This is how the plus is used in your println function. And I'm saying b equals to, so when I execute this I need to get the output as b is false. So b is, concatenating b value is false, so false is converted to string, and I'm going to b is false. Now I'm going to say b is true, again I'm printing the value of b as b is true. And if b, now what is the value of b? It is true. Hence now to evaluate if condition, I don't require a relational operator now, or I don't require 1 and 0. I can use a variable now which is going to hold a Boolean value as true in this case. So now using this value, now this condition becomes true, and I'm going to print the output as this is executed, and I'm going to say b equals false. This condition becomes false, hence I am not going to execute this. Hence I'm not going to see this output on the screen, and I am going to use println. I am just going to print this statement as 10 greater than 9 is, and plus, that is concatenation with the result of this conditional or relational operator. Now what does the relational operator returns? It returns a Boolean value, either true or false. So 10 is greater than 9, yes, it is true, and this will return true, and the true will be concatenated with this statements. 10 greater than 9 is true. Now remember, so this bracket is necessary. If I don't use the bracket, what happens? Yes, the first priority will go for the plus, the second priority will go for greater than. Hence, I'll be getting 10 is greater than 9 is 10, and later on I'm going to get some syntax error, because when I say printer greater than 9, it doesn't have any meaning. Fine. So now just look at this program and understand how exactly the Boolean variable should be declared, Boolean variable should be initialized, and Boolean type should be used in println function or in any expression or in conditional statements. Fine. Now similarly, you can just declare the variable for int, declare the variable for short, and so on. It is similar to this. Hence, I have not shown exactly how the variable should be declared and initialized in this session, because it is similar to the declaration and initialization what you have done until now using C and C++ program. I have just shown the example for Boolean, as you are new to this Boolean data type. This is fine. Now with this, we are going to have the data types. Now we'll just go to the variables in Java now. Fine. So when I say variable, you know what is a variable now. So declaring a variable, using the variable to hold a value, and so on. And so now I'll just give you a brief of how Java is going to handle a variable. Fine. And the first thing is we need to know how to declare a variable. So we are already aware of this. That is, when I say int x, it is declaring a variable. So nothing different in this. But one major difference, what you should remember with respect to C program, is you can declare the variable in Java program wherever you want in the program, and whenever you want. But you need to make sure the variable is declared inside the class or inside any method or member function. Whereas in C program, you are not supposed to do that, as we have discussed while discussing about C++ program. Hence, you are not supposed to declare wherever you want in C. In C++, I can declare wherever I want in the program. In Java, I can declare wherever I want or whenever I want in the program, but inside the class or inside a main function. This is fine. And when I say initialization of a variable or variable initialization, it is just giving a value. When I give or assign a value for a variable at the time of declaration, we call this as variable initialization. So again, nothing new to discuss in this case. And there is one new term what has been used. We are already in practice of this, but a new term has been given in Java called as dynamic initialization. That is, so when I say a equals 1.5 with a constant value, we call this as variable initialization or static initialization. But when I initialize any variable with a function call, we are going to call this as dynamic initialization. Now it depends upon what value I pass as a parameter and what value this function passes. That is what I am going to assign. And again, this is an inbuilt function what I am using to find the square root of a given number in Java program. So right now, don't think about what all this dot is, math is and all. Just understand I am using a inbuilt function called sqrt to return the square root of a given number. Hence, we call this as static initialization. We call this as dynamic initialization. And this is assigning a value. Fine. So I hope you are clear with this three term. Fine. So now we'll just see what is scope of a variable in Java and what is lifetime of variable in Java. So when I say scope of a variable, it is when I declare a variable, so where can I use the variable? So what is the area it is limited to use? Either in the entire program or only in the function what I am using in. So even if we talk about C program, the global variable what we create, the global variable can be used anywhere in the program. Hence the scope of variable is in the entire program. Whereas if I declare any local variable, the scope of local variable is limited only inside the functions what I am going to define. And with that, if I say lifetime, once the variable has been declared and once the variable will go out of scope, will go out of scope, we call this as lifetime of a variable. The time it is created and the time it is destroyed, we call this as lifetime of a variable. In C and C++, the scope of variable will be either local or global. Whereas in Java program, the scope of variable is going to limit upon the block of statement. Remember this. So this block of statement scope is also available in C++ also, but strictly not available in C program. In C program, the scope is going to be for the entire program or for the function. But in Java, the scope of variable is going to depend upon the block where you are declaring it. Fine. So to understand that, just look at this. I am going to declare int x, int a, int z. 3 variables have been declared. And this is the start of the block of code, the curly bracket, and its pairing curly bracket over here. Now this is the scope. So starting from this point, I can use the variable declared in this block only in this block. Fine. So now I am just going to have one more block of code. I am using one more pair of curly bracket. This is the second block now. This is outer block. This is an inner block. You can use nested block or you can use independent blocks. But once you declare a variable in one block, cannot be used in another block. Fine. Hence, even in this case, in the nested blocks, just observe in this case. So I am going to declare int y equals 20. And I am going to print the value of x and y. Now the value should be printed. I am just going to print the value of x, which is going to be 10. And I am going to print the value of y, which is going to be 20. And the scope of this variable is in this entire block. Wherever I want, I can use that variable in this entire block. Hence, I am able to print the value of x accessing x, which is the variable of outer block, and y of its own block. And next, I am just going to say x equals y into 2. This is still valid now. This is still valid because x is the outer block variable. Hence, I can still use this. And when I say y equals 100, this is going to be an error statement because the scope of y started at this block starting and ended at this block end. This is going to be the scope of the variable. The scope of variable limited only for this block. Hence, you are not supposed to use this outside the block. And even we are going to call this as lifetime. The lifetimes of y starts here at the starting of the block, and the lifetime of the variable y ends at the end of the block. But the lifetime of the x is still existing. Hence, I am going to say system.out.println x is. The value of x now was 10. It can be modified, it can be accessed, as it has been modified to 20 into 2, 40. Hence, the value of x is going to be printed as 40. So by this, just understand what do you mean by scope and what do you mean by lifetime. And once I come at the end of this block, now all this variables lifetime is also going to end. This is what the variables in Java is going to be. Fine. So we'll just see a few more examples with variables in Java. Now just look at this. Just look at this. I am going to create a variable int x, so which is available in its entire block. I can use x inside this block also, and I'm declaring int y. Now this is limited only for this block of code y++ and system.out.println. So now I'm going to loop this 3 times. So what value I'm going to get, because every time I'm going to increase the value. If I keep on increasing, I should get the value of y as 0, 1, 2 and so on. But I'm going to get the value of y is 0 because y is initialized to -1, and I am going to increment the value to 0 and print the value as 0. Loop back, and now the value of the variable y scope is out and it is lifetime ends, and I am just going to again initialize and create the value of y as -1, again increment the value to 0, and every time the same thing happens. Every time the variable y is destroyed and created, destroyed and created. This is what the lifetime of the variable y or any variable in Java is going to be, depending upon the block what you're going to create and what you're going to use. And just look at one more example now of variables in Java. So now I'm going to create int x1 as outer block, and now I'm going to create int x2. Now can I use two same variables? You cannot do this. It is going to be error, because so the scope of this variable is also in the scope of this block of code. In the same scope, you cannot have two separate or two same variable with the same name. It's fine. Hence, I cannot have two variables with the same name in the same block. Fine. But if it's a different block, I'm going to have one block here and I'm going to have another independent block. In the another independent block, you can have the variable with the same name, but not in the nested scope. What you're going to use like this. This is going to be the variables in Java. Now we'll just see the type conversion and the typecasting in Java. Again, this is the same what the C and C++ hold. It's almost same. Fine. Now just look how the Java has been going to slightly modify in these terms. Now when I'm going to say any typecasting, there's an implicit type conversion and there's an explicit type conversion. And Java, fine, and the Java which is going to have the type conversion, it is going to be having a implicit type conversion, and this is going to be an explicit type conversion, because we are going to have the automatic type conversion sometimes depending upon what conversion it requires, and sometimes due to incompatible types we need to use the typecasting process. Just look at this. When the automatic conversion is going to happen, the automatic conversion happens when the two types are compatible. Fine. When they are compatible, we can have automatic type conversion. And when it's going to be compatible, either both the types should be same or the destination type should be greater than source type. Now this is not with the value what they hold. This is the size what they hold. For example, if the destination type is going to be a long, which is 8 bytes, and a integer which is 4 bytes, and so now 8 is greater than 4, hence the automatic conversion can happen. Now for in this casting incompatible type, so we need to use the cast of the data type, so which we call this as explicit type conversion, and whatever the value you want to convert its type, we need to use the target type inside the bracket with a value. Now just look at this automatic type conversion, how it's going to happen. When I say int a equals 10, now I'm saying long b equals a. Now if you just observe, now this is going to be the destination type and this is going to be the source type, and the destination type is long, which is 8 bytes, and source type is int, which is 4 bytes, hence 8 byte is greater than 4 bytes, hence the automatic conversion will happen here without any issue. Hence we call this as widening conversion. That is, from 4 byte of value we have increased or we have expanded or we are widening it to 8 bytes. Hence we call this as widening conversion. Whereas if I talk about incompatible types, we call this as narrowing conversion. This is widening conversion, this is narrowing conversion, where we are going to narrow the type. If it is 8 bytes, we'll make it 4 bytes. If it is 4 bytes, we'll make it 2 bytes. If it is 2, we'll make it 1 byte. Hence we call this as narrowing conversion. In automatic, it's widening. incompatible or explicit type conversion, it is narrowing. And when you're going to do the narrowing conversion, there are two types again which I can handle this. The one is the truncation method. The second is modulo reduction method, where we use the modulus operation. So remember the modulus operation, the remainder operation. Fine. Hence we use the truncation process or we use modulus reduction. As an example for modulus reduction, look at this. We are going to have log a equals 10, and now I am going to say int b equals int comma a. Now when I am going to use the modulus operation here, I need to look at what is the range of value the long is going to use. I should look at the range of value what the long is going to use. Depending upon the range of value long is going to use, that is going to be the modulus value for us. Fine. And we are going to apply whenever it will go out of range, we are going to apply the modulus operation and we'll use that value here. Fine. I will just tell exactly how this modulo or reduction is going to work in an example in few minutes. Fine. And when I say truncation, it's an easy process. Now I'm going to have float a, which is going to be of 10.75 value. Now I'm trying to convert this to integer. When I'm trying to convert this to integer, I need not use any modulus operation. My job is just to ignore any value which is going to be after the decimal point. That is what we call this as truncation. In this cases, the Java is going to use the truncation method for narrowing conversion. In any other cases, it is going to use model reduction cases. So now we'll just see with example what this is going to be and how the explicit conversion is going to happen. And now just look at this program now. So now I'm going to have byte b, which is going to be of 1 byte, and I'm going to have int I equals 257, which is going to be of 4 bytes. And when I say byte, so remember the range of byte. The range of byte is how many values it's going to store? It's going to store 256 values. Starting from 0 until 255, it's going to hold 256 values. Remember this, the range of the byte. When I say int I equals 257 and double d equals 323.142. Fine. So now I'm going to have b equals byte of I. When I say b equals I, the automatic conversion doesn't happen because the destination data type is less than the source data type. Hence automatic conversion doesn't happen. Hence I should go for explicit typecasting. Hence I am going to use the process or the method how we are going to typecast the value what I want to convert inside the bracket to the type or destination type to which I need to convert. So I is an integer. From integer I need to convert this to byte because b is of a byte data type. Is it fine? And so now when I do this, now what's the value of b is going to hold? What's the value of b is going to hold? It is not 257. It is not 257. It is not 257 because b is a byte which cannot hold a value as 257. The maximum value what it can hold is 255. It can hold only 255, or it can hold 20 or any negative value. So then there are 256 values in total if I count from 0 to 255. And so now we're just going, when I was going to say byte I equals b, so we are going to perform the modulus operation here because remember the byte can hold maximum 255. That means it can hold 256 values. And so now I need to perform the modulus operation with 257. That is, when I'm going to have 257 modulus operation with 256, the remainder I'm going to get is 1. Hence the value 1 will be stored in this variable b. And that is what when I'm going to print this output, the value of I is going to be 257 and the value of b is going to be 1. Clear? And so now I'm going to have integer value and I'm going to have a double value now. Hence in this case it is going to use the truncation method. It's going to use the truncation method. it will just remove the value in the decimal part, and 323 will be assigned to integer. Hence when I print D and I, when I'm going to print D and I am going to get 323.142 for D and 323 for I. And when I try to assign the same double value for the byte, the first step is the truncation will happen. The truncation used in the first step. The second step, the modulo reduction is going to happen. Hence, we remove the truncation and we say it as 323. Then we are going to have modulo reduction because the maximum value it can store 255 or 256 values. Hence, the modulus operation. When I do the modulus operation, the remainder of what I am going to get is 67. Hence, when I print D and B, we are going to get 323.142 and 67. So this is how the casting of incompatible type is going to happen. Sometimes it uses only the truncation, and sometimes it's going to use modulo reduction, and sometimes it is going to use the both. And this is all about the type conversion and casting in Java. Thank you.